All right, let's keep going through this. See where we can get these last two errors. Oh, if there's more, there's probably more. 30. Kind of fun. Cool. So this either a translation exception, nothing. Either yeah, it's in the plot for sure. Okay, cool. Now this isn't working. I query result I either something and nothing. That's pretty bizarre. I'm not really. Man, wait. Um, mm, where are others at? In here, got nothing. Okay, that was easy to fix. Alright, this one's over here. Content query result of an either. With a predicate. Okay, so it does see that there's a where. Calendar event yields what? Okay, and it sees this correctly. Apply. Um, okay, or translation error. So this is calendar event yields calendar event dot subject that contains used case. Okay. The alternative is a translation error yielding true. And I do not see the difference between what I just wrote and what was already there. Um, fine. Not fine. What in the world? I don't get it. What happened? Oh, did I really not? I don't think I had the namespace in. Yep. Okay. but we still got this issue. Converting. Mm, iQuery results. Okay, fix that. But now we've got this thing. So, okay. So this is really the first time we're enumerating through one of these. So this will be exciting. So, okay, so while it has an element, um, result.nodes dot try get left. Um, my element. Okay, and we're going to want to keep traversing nodes, so I'm going to create an additional method here. So if not, query result node that try get left out of our element, um, then we're done. Okay, we did get an element. Then what we're going to do is maybe even just directly this stuff. Let's see what happens. Oh, nice. Okay, query result node. Oh, I see. Okay, okay. I don't have to do recursion, I guess is the point here. So, and I don't want to return in this case. I actually want to do that error handling code down below. Nice. Oh, look at that. So now if So the thing is, we know it's going to be try get right. I'm going to make a note for this. Yeah. Oh, these are different. Sorry, terminal try get left. Okay. So here, we know that this will be true because we escaped the while loop is left was false. See if you can use an apply or combine the two. You cover all branches. Um, so for example, when we go to write this test, right? Um, will have come through here. The compiler doesn't know that try get left and try get right are intertwined. So we're gonna eventually be trying to write it to get full coverage. We'll be trying to write a test that has a false for try get left so that we get here, and then has a false for try get right so that we get yes in this case to no code. But again, the compiler doesn't, the code coverage doesn't see that, and we also want to make sure, like in the future, if somebody writes a line of code here, we know that line's never gonna get reached. So we need to write our code in such a way that that doesn't accidentally happen. If that person isn't having the same rigor, like they'll sit there and bang their head against the wall. And but we right now we know that that's not even possible. So we should write our code in such a way where you can't even get to this unreachable line. But anyway, I'm just trying to migrate stuff to the latest code. We'll get here when we move to do list service into when we do our quality checks on to do list service. So. I think that should make all the things compile now. Everything succeeded. Love it. All right. Um, cool. So let's go back to the to-do list here. Argument null inline. I'm still not 100% that I know what to do here. So I'm gonna talk through this, I think. So this is the wow, it also has a pointer variant. That's fascinating. Anyway, so if we can get a reasonably sized window here. So the thing I'm struggling with is that they put object in here. So you can, one of the things I'm struggling with. So you can, let me maybe back up about the use case of this. So, um, the use case is like here. Yeah, this. So I don't know why I did it that way, why we wouldn't just put these in But these two are where it actually matters. We don't want to keep settings around. We don't really care about this particular instance. Let's get it garbage collected if we can, and let's move past it. So um, what we do want is these two times these two values, and so to get at these two values, and I guess to also demonstrate that part, we aren't going to have a settings instance. So what maybe seems reasonable is if we had a constructor that took in the settings instead of these two values, and then did its assertion um, and then set the values. So um, the issue with this is that when like where is called, uh, we need to return a new one of these, but we don't have a settings, and it doesn't really make sense for us to instantiate a new instance of settings just to create a new instance of calendar events context. Um, so uh, we are taking these values in directly for the where cases, in which case we can't just put the settings assertion somewhere in here. Um, the other aspect of this is um, for setting, like here, we could actually have an overload of this that doesn't take these two values in, and then we could just have this one call this and not pass it's call use that overload and not call these not pass these two values in, and then just set them directly here. And this is like semantically they mean the same thing. We want to use the same code for that. We want like this is where sharing code is actually powerful, and where um, um, forgetting the word for it, overloads. Get mad if I can't find the name for it. Polymorphism. Um, so we really want to be passing in exactly the values that we mean to the constructor that we mean. Also, a thing I see often is this like having like an initialize method that's not a constructor, so that you can do whatever other wacky things you want to do. And no, we want read-only fields. This is a read-only type. We don't want it to give off the wrong impression for maintainability's sake. It's super important that none of the future maintainers get the wrong impression that this is some mutable type, and that you should be doing things like changing page size all willy-nilly. So, um, yeah, and in my experience, you can like always avoid those initialize methods if you actually are just willing to write the code that is missing from the framework or from the repo that you're in. Like if you're just willing to write that code, you can avoid those initialize methods and have more correct code. The design will match the implementation, which helps the future maintainers who come along, which is likely you, likely me, to also do the right things when they forget things or don't remember the full context or have the full context. So that's the use case we've got here. We want to return the thing. We want to assert that this isn't null, and we want to return the thing. And actually, I think if we do it right, this will. Wow. That's pretty cool. So because it does this whole not null thing, the compiler does see that the second time we use settings, it's already not null. If we would do this, oh well, it thinks that fine. Yeah, that's the real problem with the nullable feature actually. Cool. So this proves what I was just trying to say. Um, Anyways, moving on. So here, that's what this is trying to do. That's the way in which it is different from this. I've done some super micro benchmarks in the past, and have found that the void overloads definitely, like, there's a measurable impact. If you try hard enough, you can see it. That might not be true today. I did that maybe like 8 or 9 years ago. So, but yeah, I think it's worth this overload existing because this is the most common use case, and there seems to be a perf implication for returning the value here back to the caller. Um, but as I just showed, we do have use cases where this is helpful. So what I am so I want to compare what I've written up here to like what .NET has released, and I don't quite they're not using the not null attribute. That's fascinating. What is, maybe this doesn't mean what I think it does. That an output is not null even if the core it was not null when the call returns. Huh. Parameter name. That's pretty interesting to me. I wonder if there's some compile. Let's look at the source. Oh, okay, they do use it. It just doesn't show on the learn page. That's fine. Um, cool. So let's use this instead. So they've got a nullable object here, and maybe so what's bugging me about that is public struct foo uh, argument null exception throw if null new foo. So this can be structs can be boxed. So despite that this is not an object, it can be wrapped up into something that looks like an object. And so like this is never a legitimate statement. But if we look at argument null inline dot throw if null new foo. Oh right. This will also work, but what I'm considering here is where T implements class. And now this doesn't work because this isn't like this doesn't make sense to try to do. Um, and something that let's actually open up a test and play with that for a second because um, so if we were to do this on value, uh, because it's value dot has value, right? Yeah. So this is the struct version. So I don't know. Is this going to get boxed up? Like what actually happens here? Um, Okay, okay. Yeah, so it does throw for this. Oh, this is null thing. Okay. So I would guess if this was equal null, it probably wouldn't work. So um, let's make this public for a second so we can see what happens. Um, so this wouldn't be allowed. Fine. But then argument null line of null value. Yeah, that's also not allowed. Um, okay. But then what if we have an additional overload throw null where it's a struct? Um, yeah, so now that's okay. But over here, is that okay? No, still not okay. Okay. I think this is all, it's just really frustrating to me that this is allowed. Because it's like it's gonna get boxed. It's like the most expensive no op that's ever happened. Like we know it's not gonna throw. But the person implementing it has like accidentally done this. Um, and I would love it if the compiler would just give them that error. So yeah, I actually wonder if the runtime or the jitter or yeah, the jitter is smart enough to know in the case where this is a nullable struct to like not box. Is that a thing? This is very so this is what I'm everything I'm talking about is what I'm concerned about. And the other part that I'm concerned about is some future world where public read-only ref struct um, full nullable of T where T like allows ref struct. Um, well, I don't have that here, but let's just bear with it. Allows ref struct. Um, yeah, like no, nullable today is a struct, so it can't have a ref struct. Generic. Uh, so but in the future, if they update that, or if they have this new full nullable that does allow ref structs, then I need an additional overload here. Though over here, they will also, yeah, you can't cast a ref struct to an object, so I won't be the only one needing a new overload. This, like, if I, rather what I mean is if I use what .NET already has where I have a nullable object as the input parameter, um, and then they start allowing restaurants. I'm going to need a new um, overload anyway. Um, like there's no future proofing this using object at least. I did this class thing, but is that actually necessary? Like, why doesn't this work? Is that included that? Well, what about here? Oh, okay. Does this still not work? That's bizarre. Yeah, because this is the fake nullable, the attribute based nullable. It's just really obnoxious. I at least think this is better than using object because object will still have the boxing again, of course, unless the jitter already like knows something and optimizes that, and that the .NET developers are like relying on that. Then like boxing is going to happen. So yeah, I don't have a good direction on this. I'd really like to just get this behind me, but I'd also have to hate to keep this internal just because I can't make a good decision on it. I'm gonna keep it internal is what I'm gonna do. Um, yeah, I'm gonna keep it internal. I'm gonna go with my gut here. I'm gonna have two overloads. And then something that's also really important is, do I call this here or am I writing this out? And the reason I bring that up is because, and I'm gonna just benchmark, I mean, fake benchmark this. So this is gonna be Throwville 2. So the one that I want to write is if um, argument has value. Argument not has value, return argument value, else. throw the null exception with brand name. Where's the other object? And we're gonna keep this foo. So stopwatch equals new system diagnostic stopwatch start new. Great. For I0, I is less than iterations, plus I. Argument null. Oh my goodness. Argument null. Inline dot throw if null to console right line stopwatch dot fix. This 2. And then I also want both of those for where foo equals null. Okay, let's run this and see what happens. Oh, right. Let's do this one first, because catching might really influence the search results. Uh, take 32 million, yeah. 2 is significantly faster. Okay. Wow, even faster. Okay. Now we're close enough that it might be the order that's messing us up. Let's add one more of these. Yeah. Let's do it this way for a second and see what happens. Yeah, look at that. Okay. So I don't know if it's the boxing or whatever, but I'm convinced something's awry if we just delegate to them. So I don't want to do that. Um, Same deal up here. I'm gonna um, make a copy and if equals null, null exception, uh, like, parameter. This is ever so slightly slower. There's no way that's legit. Yeah, these are so neck and neck. That's crazy. All right, I'm taking the ones that both do themselves. They point the full thing themselves. That's fine. So the other question I've got is, do I want this as an extension method? So if I go back to the usage here, like it's I'm asking, do I want to say settings dot throw if null? I actually just write that here. So just put this in front of it. Um, Settings dot throw if null dot page size. I just There's something that seems convenient about it because like we are an expression. I guess the other part too is like the Fluent API vibe here. So let's go back to the test stuff because I'm gonna play around with it. So it's like, what if I've got public field class some settings and I've got some nested settings, for example. Um, so in here I've got public nested. Oh, um, yeah, keep no, okay. So this is like new thumb setting. So bar settings with the new thumb settings. And if I want to get the value out of this to pass somewhere, it's like I've got to say set argument null inline dot throw if null settings, and then that I have to say argument null inline throw if null settings dot nested settings. Now we say dot value, whereas the alternative would be to say settings dot throw if null dot nested settings dot throw if null dot value. I mean, it is undoubtedly cleaner 151. What happens though is like value dot throw if null. Well, it's not nullable, but we just be writing code and it'll pop up everywhere. Series events dot throw if null. Like, why would I throw if null? That doesn't make sense. Um, same deal here. Like, why aren't these extensions? I mean, in this case, it's because it's on this class, but this instance type. But like, there's no reason there couldn't be argument null exception extensions as a static class, and then we have these as extensions. So I I'm gonna make the decision to all right. One, no extensions. Let's not pollute namespaces. Let's not pollute IntelliSense really. Um, since precondition checks only happen at the beginning of the method, and inline checks only happen when overloads can only be called using expressions, which is even more rare. Make a note of the trade-off with velocity. Um, keep internal. Note that you want to keep it internal because of the nullable object. Three, yes, let's restrict to only nullable types. Four, um, as a result of nullables, let's not use the .NET variants and instead write it out. Let's note the benchmarks we did to come to this conclusion. All right, that's where I'm at. Okay. Now I guess the question I still have is do I keep it internal? I don't think I've actually put something as internal yet that I in that way test into uh, doing like internals. Yeah, keep it internal, and then that would open up the other internals. And I'm not really a fan of internals visible too. Like if your behavior can't be um, doesn't manifest at the public level, then it doesn't need to be tested. And so if you're using code that um, has all those extra branches, like that code is unnecessarily complex. Alternatively, it's trying to handle additional cases that do exist, but just not for the code base it's in which case it's trying to be a more framework oriented um, API, and so we should make it public. So like I just, which is exactly what's happening here. This really should be public. Like the intent is that it be public, but it's just not really complete. I am gonna have to do internals visible too for the OData stuff at some point though. Yeah, I guess I gotta do internals visible too, which I have forgotten how to do. So in principle, I like what they're doing there, but not for this case for sure. Because like this is I don't want to be doing this everywhere. I don't want to be that general purpose. This is a specific case that I'm lighting up here. So okay, let's actually go through this now and actually and do it fully. Um, So what we found was I'm going to use my implementation only, or not try to reuse the .NET implementation. So let's do this, and then uh, let's make our notes. Considered making the methods extension methods design decisions. However, doing this pollutes intelligence. The trade-off is between the uh, constant intelligence pollution versus the Fluent API. Fluent API calls for inline checks. Comparing the uh, Fluent API to non-Fluent API, we have something that looks like compared to, let's pull this over. So it's this. The Fluent API definitely wins out, but having intelligence, but precondition checks only happen at the beginning of the method, and inline checks only happen for cases where expressions are required due to certain uh, restrictions while calling overloads. Uh, Beginning of the method, which is a small portion of the, the entire method, such as constructors. And these cases only are extremely rare themselves. As a result, I have chosen to not introduce the Fluent API because the case is so rare that it is, and the Fluent API only really helps for cases where nested checks are needed, is which is absurdly rare. because, for example, using the above example, y hasn't settings already asserted itself that nested is not null. As a result, I've chosen to not introduce the Fluent API because the use cases seem to be so rare that benefit would be far out or exceeded by the detriment of every intelligence being polluted by a method that is not. Okay. Second decision is okay, considered following the precedent of .NET and using nullable object as the input parameter for uh, these methods. However, didn't want to do this because it allows for structs to be passed in. This is the result of implicit boxing, which can have performance impact. So it further we know that those structs will never be null. So this becomes very expensive no of all the decisions. This is the one that is keeping this class marked internal. If something happens, the third decision is I considered leveraging the existing .NET methods to perform the actual null checks and did some micro benchmarks, pseudo micro benchmarks, which indicated that particularly the struct case for the struct case, boxing is introducing a performance impact. Similar benchmarks also demonstrated that Either there's no difference for the class case, or that the custom implementation wins out slightly. Okay, this is what we got then. Delete all this stuff. Go to view. Oh, I kept all this in V1. Whoops. Okay. Whoa, what? Yo, that's crazy. I don't make internals visible too. What does that mean? You know what? Do I need a separate project for internals? Maybe. All right. Let's just get back to work. All right, so we've got the comment line. Um, we're in the right namespace. Our using statements are valid. Uh, we're non-instance types, so most of that stuff doesn't apply. Preconditions checks. We are the precondition checks. Exception documentation thrown if this, okay. And if agreement is null. All right. And then to-dos. Cool. Everything that isn't nailed down 100% should be internal. This is internal. This is instance types or static, so we don't need this dot. Call exceptions, no called exceptions, no using pragma, no scoping. Line lengths. Awesome. Let's make this not a giant block of text. Other line lengths, yes. Down here. Okay, we got the line lengths done, and now we're for some unit tests. So now I have to make a decision. Um, is there anything else internal that I'm already testing somehow? It's all FX core. Let's ignore FX core. Okay. I'm gonna I'm gonna do it. I'm gonna create a new test project. For the internals. Now over here, gotta make this internals equal to oddtrotter core internals test. Okay. So, let's make sure that still compiles. Okay. So now in here, let's do add, what is it, calendar v2, add new folder, calendar v2, system, argument, null inline test. Do all that, do this. Not that one. Put one of these up, put this stuff. Okay, so test this stuff. Um, null class, private field, mock class, mock class, class. Um, argument, argument null inline, throw null class, insert throws exception. Okay. And now nullable class. Let's make this nullable. Make sure it all still works just fine. Okay. Test method. Null class. Throw if null, non-null class. Mock class. Assert, and then var return equals argument null inline, throw if null class, assert r equal class and return. Okay. All right. That is all for today. We'll